All right, here we go. Unit 6, Day 5 notes. This is for Friday. Our last set of notes for this unit. Monday, you're going to get a review. Tuesday, you will do an assessment. So this is the notes for the last part of this unit. Hopefully, we're going to finish strong. Remember, this is the last unit before finals. Finals are coming up pretty quickly. We want to make sure we finish on a high note. All right, let's get started. So I look at this, there's a couple things I need you to remember back from a couple units ago when we were talking about rotations, transformations, dilations, all that subject. And this is kind of that reminder of some vocab and what you need to see and kind of keep in mind as we move forward, all right? The first thing is we're going to talk about image and pre-image. Remember, it doesn't matter what letter I use. B is always going to be considered to be the pre-image, and it doesn't matter if I use B or X or Y, any of that. Without the little tick mark above it, that's always going to be the pre-image. And then anything with the tick mark above it, we call that prime, right? B prime here. This is going to be our image, right? This is going to be our image. So those are the kind of concepts I need you to keep in mind. Remember, we have a pre-image and an image. And that is taking a shape and dilating it, making it either larger or reducing it and making it smaller. All right, here we go. A transformation that produces an image that is the same shape as the original, but not the same size, okay? That is a dilation. It's a transformation where the shape stays the same, but the size is different. So we want to use the idea that it's a different size. Different size. And remember, that's what makes it not isometric, right? Isometric means the same shape and same size. Not isometric is either, well, it's going to have the same shape, but not the same size. All right. And dilations are centered on the origin. This is a key thing right here. This is pretty big. Dilations are centered on the origin unless otherwise stated. So it's always going to be, when we do this on a graph, the center is always going to be around the origin or point 0, on the graph, unless you're told otherwise, okay? So that's always going to be the center. All right. If the scale factor is greater than 1, well, remember what the scale factor is. That's where like K equals, right? K is our abbreviation for scale factor, K, all right? If the scale factor is greater than 1, the figure becomes larger, right? Larger. If it's greater than 1, the figures become larger, and that's called an enlargement. If the scale factor is between 0 and 1, so below 1, between 0 and 1 means less than 1, right? But greater than 0, the figure becomes smaller. And we're going to call that a reduction. So we'll use the terms enlargement and reduction with this unit, okay? Enlargement and reduction. All right, let's move on. Determine whether the situations are reductions or enlargements. Reading the directions, I'm asking whether or not these are reductions or enlargements. As I look at this, here, this point right here, this is going to be my origin for this graph. That 0 right there, that point with the red, is my origin for this graph. And when I look at this, my prime is closer than my pre-image, right? It's closer than my pre-image. So my B prime is closer than pre-image, right? It's closer than my pre-image. So what does that mean? Is that an enlargement or is that a reduction? Well, remember, if I start at the pre and I'm moving one way or the other, in this regard I'm moving closer, that means I am reducing or becoming a reduction. So this first one is a reduction. The second one, my origin is this 0 right here, my pre-image, and then my image, right? My image, so this would be called an enlargement. It's because my image is further away than my pre-image. And the last one, it says the scale factor is 2/3. Well, is 2/3 greater than 1 or less than 1? Hopefully, if you don't know, you just put in the calculator to see 2/3 is less than 1. So this would be called an reduction. All right, hopefully you understand. If any time you need to pause, please do. Pause it, ask questions, do whatever you need to do. We'll get going. All right. The next one, find the scale factor. So find the scale factor and determine the type of dilation. Determine the type of dilation. So the first thing I need to do is find the scale factor. And that will lead me to what type of dilation this is. All right. One of the thoughts I need you to put into your head is, whenever I'm doing this, I want image over pre-image. So image over pre-image. And the reason why I want you to keep this in mind is it will help you keep which one goes on top and which one goes on the bottom more accurate. You'll be able to keep closer tabs on that, okay? Because sometimes you're going to be able to see whether or not the graph or the image becomes bigger or smaller just by looking at it, but you may put it in the wrong space or the wrong spot in the terms of the fraction. So therefore, you may tell me that the scale factor is larger when actually it's reduction, and you knew it's reduction, but you didn't put it in the right spot. So always put image over pre-image. In this case, my image is 15 because prime, all this is 15. My pre-image is just 7. Well, that's my scale factor. It's 15 over 7. If I look at this, well, 7 goes into 15 more than 2 times because 7 goes into 14, 2. That's 1 left over. So that's more than 2. Is that greater than 1? Well, of course it is. So this is going to be enlargement. Ah, and the next one, I'm looking at it. I want prime or image over pre-image. Prime over pre. If I look at this one, prime or my image is 5. My pre-image up to P is 10. Well, what's 5 over 10? If I reduce that down, that's 1 over 2. Well, that is my scale factor. So 1 over 2 is my K, right? Is 1 over 2 larger than 1 or smaller? Well, of course, it's smaller. So this is going to be a reduction. Ah! Hopefully you're catching on. We're moving on. Next one, it says, find the scale factor. Tell whether the dilation is a reduction or an enlargement, and then find the variables or the value of the variables. So we're doing 3 things here. Okay, we're doing 3 things. We want to make sure we're checking that. Also, let's look at this. I've got a prime, I got a pre-image, an image. I've got a lot of funky shapes here. Well, as I do this, I need you to realize we're talking about this image and this image right there. So I've drawn it in green. Those are the 2 images I'm comparing. All right? So as I look at this, I want to find the scale factor. Well, can I compare a side to a side? Because that's how I find the scale factor, is comparing one side that's similar to the other. So I look at this, I've got a y goes with a 4, can't do that one. An 8 with the x, can't do that one. I've got a 12.5 to the 5. Well, I can do that. So k is going to be equal to 12.5 over 5. Well, what's 12.5 over 5? Get my calculator out here. That's going to be 2.5. So k is going to equal to be 2.5, or I can write 5 halves. Remember, 2.5 is 5 halves as well. I can use either one of those, okay? So as I look at this, now I know my scale factor. So now I need to find out if it's a reduction or an enlargement. Well, if it's 2.5, is it a reduction or enlargement? Well, the scale factor is greater than 1, so I know that this is an enlargement. Okay? So we know it's an enlargement. We've answered 2 of the 3 questions already. Let's do the third and final. Find the value of the variables. Well, we need to find x and y. So let's go ahead and use our scale factor, 5 over 2. And now I want to find the x. I want to find the x first. So the 12.5 over 5, or 5 over 2. So this becomes x over 8. Remember, bigger to smaller, right? Bigger to smaller. This becomes 2x equals 40. Divide by 2. And x is equal to 20. Hopefully you got the same thing I did. Now, let's do it for y. Well, once again, I can still use my scale factor here. And now I have y over 4. And that is a y there, over 4. Well, this becomes, cross multiplying, becomes 2y equals 20. Divide by 2. And y is equal to 10. Connect my y there. So y is equal to 10. So you should come up with x is equal to 20, y is equal to 10. All right, let's do the next one. Let's look at these images. Which ones are we trying to use? We're going to do the outside box. I'm trying to go on the outside of it so we can keep some stuff clear. And the inside. Let us find the scale factor. Well, I want prime over pre, right? Image over pre-image. So when I look at this, which sides can I look at? Well, I've got widths, I've got 7 and 12. I can look at that. I got 18 and x and whatnot. I'm going to use k is equal to 7 over 12 because this 7 and this 12 correspond directly together. So that'll be able to give me my scale factor. And is 7 over 12, is that larger than 1 or smaller than 1? Well, 7 over 12 is not greater than 1, so this is going to be in a reduction. Now, you could have said, hey, I can see that already because my pre-image is here and my image is here, so I know that's a reduction. You're absolutely right. But making sure we write it correctly allows us to be able to move forward with the algebraic part of this. All right, next part. I want to find the value of x. Well, we want to do this. Let's use our scale factor. We're going to use 7 over 12 is equal to, well, what is that equal to? Well, 7 over 12, and that's going to be x over 18. And the reason why is, and I know that these sides are going to be the same. So as I do this, I can use the 18 comparing to the x. So this becomes, cross multiplying, becomes 12x equals 18 times 7. 18 times 7 is 126. Divide by 2, and x is going to be equal to, what's 126 divided by 12? 10.5. 10.5. Holy cow, that didn't come out very well. Let's do that again. 10.5 10.5. So you should have x is equal to 10.5 as you do this. All right, hopefully there's any questions, feel free to ask. We'll get going with the backside. All right. This is going to have one part that's going to be pretty easy and one part that you're going to go, oh, this is too much work. It's a little bit of work, but you can do it. I promise you, you can. Okay? As you look at this, it says work backwards to find the center of dilation. You want to find the center of dilation. And you also want to determine the scale factor. So we want to find the center and the scale factor. Well, how are we going to do that? I'm going to show you right now. All right. The first thing is, when you see this, I want you to draw a line from the pre-image to the image, and I want you to extend that line out. So you're going to draw a line or connect pre-image to image. And I want you to extend that line out, okay? I want you to extend it out. That's how we're going to find the center. It's nice and easy. As long as you do it correctly, it's nice and easy. And it's not, this isn't the tough part, okay? This is going to be the easy part, to find the center. And then we want to determine the scale factor. Well, we've been using numbers already given to you. We're going to have to use the distance formula. So we're going to find, for the scale factor, the distance of two sides. Okay? And I'll explain more about that here in just a second. Let's find the center first. So I want to connect my pre-image to my image. So when I do this, I want to draw a line. I'm going to freehand this, but best thing is to use a ruler. And I'm going to draw a line and I want to extend it out. I want to do the same thing with all 3 points of this particular object, which is a triangle. And I'm going to connect all pre-image to images. I'm going to draw that straight line. Notice all 3 lines intersect. That is very, very important. Where they intersect, this spot right here, is the center of my graph. 1, 2, 3, 1, 2. So my center is at 3, 2. My center is at 3, 2. Now, looking at this, can I see if this is a reduction or an enlargement? Well, just visually, I know that this is a reduction. And I'm going to write it so you can see it, but this is a reduction. I know that. I haven't asked that question, but I know it's a reduction. I need to find my scale factor to prove it, though. So here we go. We're going to have to use the distance formula. I know your favorite, right? Distance formula. So remember, distance formula is the square root of x2 minus x1 squared that plus y2 minus y1, and you get that squared. Remember, a lot of that can go into the calculator underneath when we do some things there, okay? So I'm always going to go from A to B and A prime to B prime. So I want to do, let's write it in a different color so we can see. I want to write from A to B and from A prime to B prime. That's the distance that I'm going to use. So as I move forward, my distance, my point, A to B. Well, A, 1, 2, 3, 4, 5, 6, 7. Point A, I'm going to write it here. Point A is at, what is that? 6, 7, 7, 4. Point B is at, where would it be at? B, 5, 0. And then A prime is going to be at 5, 3. And B prime is going to be at 1, 2, 3, 4. Wait, 1, 2, 3, 4, 1. So 4, 1. Now, all I have to do is plug those values into the formula. So once I mapped it out and I knew where the A was, B was, A prime, B prime, where those are, now I can just plug them into the formula. So the first one, AB. AB, let's do this. 7 minus 5 squared. 4 minus 0 squared. Well, create myself some room here. That becomes 2 squared plus 4 squared. Well, 2 squared is 4 plus 16. So that becomes the square root of 20. So I know from AB that's a square root of 20. Well, I need to reduce that. Remember back in Algebra 1, I can reduce it by pulling out a perfect square, right? I'm just going to write it. This really is the square root of 4 times the square root of 5, which becomes 2 square root of 5. So I know the distance of AB is 2 square root of 5. All right, so let's do A prime to B prime. I'm running out of space, and you can see that. So what we're going to do is we're going to turn the camera a little bit, and I'm going to write on the dry erase board here a little bit, so you can see that a little bit, okay? So A prime to B prime. A prime to B prime. Hopefully you can see me as you see what I'm doing. So A prime, square root of 5 minus 4 squared plus 3 minus 1 squared. That becomes the square root of 1 squared plus 2 squared. That is 1 plus 4, or the square root of 5. That is the square root of 5. Okay? Hopefully you got the same thing I did. So as I look at this, I know I want prime over pre, right? Image over pre-image. So my image is the square root of 5. So square root of 5, I'm going to write it right here, over 2 square root of 5. Well, remember about fractions. What's in front of this? Well, it's a 1 that goes out in front of that, right? 1 out in front of the radical. Well, the square root of 5 and the square root of 5, they cancel out, leaving me just 1 over 2. Is 1 over 2 greater than 1? Well, of course not. It's half. So I know that it is a reduction. Okay, it's a reduction. All right, let's do another one. I probably won't go through the whole distance formula because we know how to do that, or hopefully know how to do that, and we'll get more of that. Okay, this will be your last one. We're about 23 minutes in. We need to knock this out in about 2 minutes so we can get going. All right. First step. Connect all of the prime to the pre-images. Prime to pre-images. So as I draw this, trying to freehand this, hopefully I do a good job. Good. All right, so I got 1, 2, 3, 3, 3. So I found my spot, and my lines aren't exactly as straight as I want them to be, but it does cross at 3, 3, so I know my center is at 3, 3. With you, you should have a ruler, draw them straight. You will come across 3, 3. Absolutely. Okay? Now let's find the scale factor. Well, think about it for a second. Is this bigger or is this a reduction? Well, it's going to be an enlargement. I know this just by the fact that it's bigger out. It's bigger, it's further away than the center. So I know that this is an enlargement. I know I don't need that right now, but I have it anyway. Now, we need to find the distance of every one of these, so I'm always still going to use the distance from A to B and from A prime to B prime. I got my trusty thing here. Here we go. If I looked at A is at 1, 2, 3, 4, 5, 6, 6, 4. So my point A is at 6, 4. B is at 5, 2. And then primes, or my image, however you want to think about that. 1, 2, 3. Negative 3, 1. And B prime, negative 1, 1, 2, 3, 4, 5. Negative 1, 5. From here, plug them in to the distance formula. Plug them into the distance formula. From AB, AB is going to end up with AB. The distance of AB is going to be the square root of 5 again. From A prime to B prime, your distance is going to be 2 square root of 5. I picked the same because I wanted you to see how it changes. Okay? So from A prime to B prime, 2 square root of 5. Now hopefully you're doing this on your own. You're plugging into the distance formula and seeing that I've got a square root of 5 and a 2 square root of 5, and you know how I got that. Okay? Hopefully you're doing that on your own. Well, I'm going to trust that you will do it on your own. Some of you I know are going, no way, I'm never going to do it. Some of you are definitely going to do it, and that's the best way. Okay? As I look at this, I want prime over pre, or image over pre, so I'm going to go 2 square root of 5 over square root of 5. Once again, the square roots of 5 cross out, leaving me just 1 there. So my scale factor is a 2 over 1. Verifying that what I can see that it is an enlargement is an enlargement. All right, any questions, feel free to ask. I saved 2 on the back side of these notes in case anybody wants to ask in class. Happy to go over them. All right, enjoy your weekend. We'll see you on Monday.